Welcome back to Silicon to Software. I'm Imran. 20 years in PCB manufacturing, 20 years watching hardware promises come and go. Today we're talking about edge AI chips and why they're quietly replacing the cloud for a huge chunk of what AI actually does. Let's start with a scenario: a self-driving car doing highway speed. A child runs into the road. The camera sees it instantly, but here's the problem. The AI making the brake now decision isn't on the car. It's sitting in a data center hundreds of miles away. So think about what that actually means. The image has to go up, get processed, come back down. Best case, that round trip eats up somewhere around 1/10 of a second. Worst case, twice that. Now, a car moving at highway speed covers a lot of ground every second. Do the math on that round trip, and the vehicle's already traveled several car lengths before the brake command even starts its way back. That's not a hypothetical. That's the entire argument for edge AI in one scene. If your AI can't think where the action's happening, it's not intelligent. It's just an expensive lookup table with a latency problem. So what is edge AI actually? Simple definition: running AI directly on the device. The car, the factory camera, your phone, no trip to a server required. And that gets you three things the cloud can't promise. Speed, because inference happens in milliseconds, not tenths of a second. Privacy, because sensitive data never leaves the device. And resilience, because the system keeps working even offline. Now let's talk cloud limits. Training a massive AI model still needs the cloud. Nothing on the edge can touch that job. But running that trained model billions of times in real time, that's where the cloud starts to strain. Bandwidth is one problem. Cost is another. Sending every camera frame to a data center adds up fast, and edge inference cuts that bill dramatically. Privacy's the big one, honestly. GDPR, CCPA, they're only getting stricter. Keeping data on device helps. But let's be straight about this. Edge AI doesn't eliminate security risk. It just moves it. Firmware attacks, supply chain risk, physical tampering, these are real. Self-driving cars already have documented hardware security gaps in exactly this space. Now, the chips making this happen: neural processing units, NPUs, purpose-built for AI math, unlike a general CPU or GPU. Apple's doing it in the M4 chip. Qualcomm's doing it in the Snapdragon 8 Elite. NVIDIA's Jetson AGX Orin. That one's out there in robots on factory floors right now. These chips deliver serious compute in a package that sips power compared to a data center GPU. And here's one worth watching: RISC-V, open architecture, no licensing fees. ARM still dominates today, but that gap is closing. Then there's TinyML, AI running on microcontrollers smaller than a postage stamp, sipping microwatts of power. We're talking billions of these devices. Wearables, industrial sensors, all of it. Now here's what most coverage skips entirely: the circuit board underneath all of this. Edge AI chips need serious PCB engineering, high-density interconnect designs, real thermal management, because these boards run hot under sustained AI workloads. This isn't just a software story, it's a hardware story, from the silicon down to the copper, and it's already deployed, right now. Factory floors are running AI vision systems that catch defects in single-digit milliseconds. No cloud round trip, no waiting. So here's what this means if you're just getting into this space. Cloud and edge aren't rivals. Training stays in the cloud. Inference is moving to the edge. Watch NVIDIA, Qualcomm, Apple, and the startups pushing specialized silicon. And remember, the real competition isn't raw compute anymore. It's compute per watt. The cloud gave us AI at scale. Edge chips are giving us AI at speed. That's the story on edge AI chips. For the full technical breakdown, the sourcing, and the numbers behind everything I just walked through, head to silicontosoftware.com. Until next time.